Hello everyone, my name is Juan Andrés Cuellar Jimenez. I work at the University Complutense de Madrid, and I'm going to tell you about an exam that we did using the magnetometers in the smartphone. Okay, the contents of the talk, we're going to show first how this idea came to be, why I thought I had to change the exam, the three parts that compose the exam that we did. I'm going to talk about the evaluation process, I'm going to talk about some difficulties we had on the way, and at the end I'm going to show some results of an anonymous survey the students took. First of all, this idea of thinking about the magnetometers in their smartphone came out during lockdown. Some of my peers were working on innovation project, and it was called Smart Face utilizando los teléfonos móviles en el aprendizaje de la física. They invited me to participate, and my contribution was the design of the magnetometer experiments. We worked with the app Firefox, developed in the Aachen University, and that app allows the access to the smartphone sensors. When I got to this course, I thought that I had to change the exam because I found in the past years there had been a written exam based on equation solving. And having seen that this is a course that is called Laboratory of Electricity and Magnetism, I don't want to evaluate their capability to memorize equations, and I don't want to evaluate their capability to replace numerical values on an equation. So I thought, let's make use of the innovation project, the thing that I just worked on. I'm going to use the smartphone, and I'm going to make them measure magnetic fields in the way that I designed the practice, making them think and making them design. A little about the method. First of all, I explained to them some things I expect. Let me read from the exam. At different points of this document, I ask questions like, how many magnetometers are in your smartphone? I don't expect that you have studied a smartphone structure in any class. I don't expect that you know this because of popular culture or because it is normally published in magazines. When I ask a question like this, I have a very clear objective. I am leading you through the inductive method towards the necessary information, in such a way that I ask a question which I know you can answer due to your physics knowledge, and what I intend is that you go through a thought process, finding your own answers from your own logic instead of giving you the plain data. Why did I write this? Because when I was taking this idea in my companions in my research group, one of the PhD students was very angry, and she told me I cannot grade the students based on their knowledge on the smartphone. And that's not what I want to do. I want them to think on the physics that is involved when you use the navigation app and you have the compass that is telling you where is the north. If you are aware of what is necessary from the point of view of sensors to be able to use this thing in any direction and anyway getting the north correctly, then you're thinking about physics, you're thinking about the interaction between the magnetic field and the magnetometers, and that's what I want. I don't expect them to know the number of magnetometers in the smartphone, and that's what this phrase means. I also told them that I expect them to think from the black box perspective, not to look up the information on the internet, but to think about it. I told them to allow themselves to make mistakes, because it's very easy, and it's not important if you make one or two mistakes. In the middle, what I am evaluating is the whole process, and the objective of the exam was to design their own experiment, not to have from the beginning all of the answers. So the first part was to identify the axis. There's lots of things we don't know about this thing. We don't know what is the magnetometer location, we don't know the geometry, we don't know if they are calibrated or not. But what we do know is that navigation apps use a compass, and if you think a little about it, you can tell me how many magnetometers are necessary, and that's the first thing I asked them. The second thing that I asked them is, what is the expected measurement range? If they think that they are measuring the magnetic field of the Earth, then they can give me a number. And if they don't know it, at least they know what is the number that they have to look for in order to know the measurement range that they expect. After that, we go to the research part, where they have to find the answers. So first of all, I asked them to design the experiment, explain the interactions that they expect to see, what are the things that they are going to measure, what shapes they expect from their measurements, and just by using the Earth's magnetic field in order to identify the X, the Y, and Z directions in their phone, because as is shown in the upper right side, there is 3 magnetometers in the application, and if you haven't thought about it, then you have to be capable of thinking what is that and what for is it there. And the last question is, are the magnetometers calibrated? Is it important? Because let's say, for example, that right here where I am, the magnetic field of the Earth is 42.5 microtesla. Is it really important for the compass app if my smartphone measures 40 instead of 42.5, if it measures 50? So they have to think about it, because the objective of this app is to give me the north. So we know that the sensors are not really military calibrated, but they are capable of making measurements. So let's see some of their answers. They report some measurements they did by screenshots, and some of them made drawings, some of them took pictures. Anyway, I'm really happy with these results, because when I was designing this idea, when I was thinking about how to make this problem, I've talked about this with some of my peers, some professors, some doctors, some teachers, and they were not capable of finding the answer in 15 to 20 minutes. If I tell you right now the answer, then you're going to say, okay, it's obvious. But if I don't tell you anything and I just tell you use this and the Earth's magnetic field and tell me which one is X, Y, and Z, then it's not so easy and you have to think about it. So the fact that they gave me these answers makes me very happy, because it's not something obvious and they got to the expected answer. The second part, now that we know which one is X, Y, and Z, let's find out where they are, because normally magnetometers are a small thing. We need to know where they are, because magnetic field falls down with the distance very rapidly, so it's very important to have them well located in order to use them as a sensor unit. And here are some of the pictures that they report of the setups they built in order to find out the magnetometer position. Part 3, and this is the part that I really wanted them to do, is to design a Biot-Savart experiment. After all the things that they have done, we have to think about 3, especially 3. How high was the maximum measured field? Because that's going to tell them how high a magnetic field can their smartphone measure. They have to determine the measurement resolution from their previous measurement. They have to be able to tell what is a signal and what is noise. And the last thing is they're going to use an equation that has a parameter that is x, the distance between the sensor and the center of the coil. So they have to be able to make an estimate of where is the position of the sensor in order to have an estimate number for x and make some calculations. Other things about the measurements. We cannot know some things when this practice is done at home. We cannot know the internal resistance of the batteries, we cannot know the wire resistance, and we cannot know what is the applied current, even though we can make measurements and we can analyze them. That's what I want. I want some measurements, I want some ideas, and I want some analysis, because that's what I'm going to evaluate. I told them make at least 2 measurements. Use different types of batteries, or use them in different configurations, or maybe you can use different loops with different radius, whatever you want. They did lots of things, and by using the equation and the measurements, they gave an estimate of the delivered current by the batteries. That's what we asked. Let's see some of the reports, some of the images they reported. This shows that they thought a lot about it. They built different things. One of these things that gives me surprise is the paperboard thingy with the loop around and the magnetometer in the center. They thought a lot about this, about how to have the sensors in the middle of the loop so that the measurement will be correct. So that's what we wanted, that they think about these things, that they use things they had at home to be able to create a setup like this for a measurement. About the evaluation, then what we grade is their design, the capability to identify the X, the Y, and Z axis by thinking in the interaction between the Earth's magnetic field and the magnetometers when they move this system. If they are capable to understand that, they understand that there's a vectorial decomposition of the Earth's field and that they know what is happening when they move it. Also, when they have to find the position of the magnetometers, it means that they are capable of interpreting the interactions between a small magnetic element and the 3 magnetometers, because it's not just one, so they have to be able to visualize the shape of the magnetic field and that what is the thing that they are measuring. So it's not obvious to have a small earphone scanning the area and then interpreting those measurements. They have to be able to understand the interactions between the magnet and the sensors. And finally, what we evaluate is their capability to apply the concepts that they know. We ask them to report the photos of their setup, to report the measurements by screenshots. That way we know that they did the job, that they did the work. And since each picture is different and since each telephone is their own, we can see that all of them did the work. And we evaluate their data analysis, not the numerical outcomes, because we cannot control the numbers here, but we can evaluate the way they think, the way they are analyzing the data that they get. And we made them think about metrology, about measurement concepts like resolution, like noise, and like the measurement range. I'd like to talk now about some criticism I received in the middle of this practice. The first thing that some people told me is students will copy. Okay, by seeing the reports, I can tell you that lots of them did not copy, because I see lots of pictures of people doing things with their smartphone. What we are evaluating is the fact that they do the work. So if everyone shows the same picture, okay, they're copying, but no, each smartphone is different, each configuration is different, each idea is different, so I can tell that the students did not copy. They had fun, and when you're having fun, you don't want to copy. One of the things that happened is that a group came to look for me, and they told me, a teacher just passed around. They asked us what we were doing. When we explained, he said, it is stupid to try to measure the electromagnetic field with a smartphone. I think this person didn't know really what was saying, because when each time we use the navigation app and we try to see if I have to go through this street or this street, we are measuring the magnetic field of the Earth. And if we check the numbers, they are good. Of course, this is not a military grade sensor, but it's a good sensor and it's capable of measuring the Earth's magnetic field. So the thing that this professor told them is just harm, because it makes them think that they are wasting the time, and it's throwing them off the path of the exercise, because now they start to worry about the meaning of what they're doing, if it's worth something or if they're just wasting the time. Another criticism I received was, if they are not sitting in silence in front of the paper, then it's not an exam. I have nothing to say to this person. We simply do not share the ideas about what is teaching and what is evaluation and how can I prove that they have learned something or they are capable of analyzing things. Criticism from some students. 7 months after the exam, I asked them to fulfill a survey. 100 of them answered it among the 260 students that we had in this course, and 2 of them wrote that they thought it was a waste of time, and one of these 2 wrote that he thinks he learned nothing. But we can show from this that they are mostly happy with the outcome of the practical that they did. They think that it helped them to learn 7 months later. They are capable of remembering the things that they did on this exam easily, and more easy as compared to other courses. So we think that this is a good result. And finally, the conclusions. The innovations in grading are that we evaluate the process, not the numerical outcome. We make them think when we use the inductive method. That's not an innovation, it's really old, but to use the method here to teach, that's the innovation. We used a hands-on approach to evaluate these scores, which was evaluated before by means of a written exam. We asked them to report photos, to report their measurements by showing screenshots. We evaluate their analysis, not the numerical outcome, and we evaluate their comprehension and their capability to apply the concepts that they know, not their capability to memorize a phrase or repeat it. Instead, we evaluate their capability to use this knowledge, these concepts. The innovation in the method, it's because now we're using the smartphone as a sensing unit, and this led to the fact that most of them found the practical fun, and most of them reported having learned more through this kind of activity as compared to the traditional classes. And as a last item, I would like to say, dare to innovate. Do not let criticism discourage you, because there are people still in resisting the new methods, the new ideas. Thanks to all of you for the attention.